So I mentioned in the last video, if you're deeper than about 50 feet or so, then, or 15 meters, then 500 psi may not be enough gas to get you safely to the surface in all situations. And so for that reason, it's important to know when you should start ascending. At what pressure on your SPG is it time to start heading up? It's also really good to know how long can I expect for my gas to last. And so it is possible to know these things. All it takes is a little bit of math, which I've done for you here. But this is a table that I use on my own personal dives, or at least a similar one to this. And if you're taking a course with me, then I provide a laminated copy of this so that you can have it with you for planning your dive, or for during the dive. You can pull it out of a pocket and look at it. But this is a table that gives you an idea of when you should start ascending and how long your gas is going to last. And so there are a number of assumptions that go into the math behind this. And one of the important ones I'd say is I'm assuming that you are breathing 20 liters of gas per minute, or the equivalent of that at the surface, what we call a sac rate. So 20 liters per minute. And that is typical of most people. But if you are particularly petite, then you may go through less than that. If you are working harder or a large-bodied individual, then you might go through more than that. If you're stressed out, you might go through more than that. And so this assumes a sac rate of 20 liters per minute. If you don't know your sac rate, then you can figure that out by downloading your dive profile. For example, off of the Suunto ZoopNovos that we use in our program, you can download your dive profile and compare that with your starting and ending tank pressure and figure out your sac rate and see how well this compares. But anyway, so let's go through this table and talk about the different things on it. So first of all, to note is that this table shown here is specific for an aluminum 80 cylinder. That's the most common kind out there for recreational diving. They're also the kind that most of ours in our program have, and so that's the table I got for you. But if you are diving a different kind of cylinder, then all these numbers are going to be different. The blue columns here show depth. So we've got depth in feet, meters, and then also the ambient pressure at those depths, expressed in atmospheres. It's important when you're planning your dive that you are always rounding up to the next greater depth. So if I was planning on doing a dive to 33 feet, 10 meters, then I would want to look at the column for 40 feet. 12 meters, because I want to round up and be more conservative rather than less. So here we've got PSI per minute. So for example, if I am at 40 feet and breathing 20 liters of gas per minute, or the equivalent of that at the surface, then I would expect to go through 59 PSI a minute. And so these kind of numbers are helpful if you're swimming around and you look at your SPG, to have an idea in your mind of, all right, how long is it going to be until I get down to, let's say, 1500 PSI or something like that. So PSI per minute at those depths. This next column here is the ascent pressure. This is, or what is sometimes called rock bottom. And this is intended to be the pressure in your SPG at which you should start ascending. This is enough gas for you and your buddy to be able to get safely to the surface, even in the worst case scenario. Now, the worst case scenario, gas-wise, would be your buddy is out of gas for whatever reason. They don't have breathable gas that they can use, and so they are sharing your cylinder. So now you need gas for both you and your buddy to get to the surface. You're also probably a little stressed out by this, and so I've upped your gas consumption rate a bit. And I've also given you a minute of problem solving on the bottom before you start heading up. And so this is my recommendation for being able, even in that worst case scenario, to be able to hit the surface and still have 500 psi of gas in your cylinder. And I don't drive it all the way down to zero because SPGs are not always super accurate, or they're not accurate in the high and low ranges as much as they are in the middle. So we want to have a little conservatism there. So that's when you're planning your dive, you want to plan that dive until you reach this PSI. Now it's time to start ascending. The next column here is bottom time. So this is how long you can expect for your gas to last from a full cylinder down to that ascent pressure. So if I've got to dive to 30 feet, then I can plan on a 49-minute dive until I reach 550 psi. That's just the gas management side of it. And then lastly here is these same kind of columns, but including a safety stop. Because if you're diving deeper than about 40 feet or so, then a safety stop is a good idea. And so, so here, same kind of thing, but including a 3-minute safety stop at 20 feet. So altogether, this is the table, and I hope it will be useful for you in planning out your dive. There are a few caveats you should know about where this table is no longer accurate or reliable. So one of which is if you have a higher SAC rate, higher than 20 liters a minute, then this table will no longer be accurate and you need to be even more conservative than that. Also, if you are ascending slower than the suggested 30 feet or 9 meters a minute, if you're ascending really slow, then you're going to go through more gas, and so you need to leave the bottom earlier. For these ascent pressures, I've given you a minute to solve whatever problem you have before it's time to come up. Let's say your buddy ran out of gas and you have a minute of like figuring out what's going on and calming down and whatnot, getting to the ascent line. If you need more time than that to start heading up, then you need to be leaving earlier before these pressures. And then lastly, for these bottom time calculations, this is assuming that you have a full cylinder at 3000 psi or 210 bar. If you got a short fill and you don't have that much gas, then your bottom time's not going to be that long. So that's the gas supply side of it, a brief introduction to it at least. And so in the next video, we will talk about the decompression obligation side of it.